A pantograph is a mechanical linkage connected in a manner based on parallelograms so that the movement of one pen, in tracing an image, produces identical movements in a second pen. If a line drawing is traced by the first point, an identical, enlarged, or miniaturized copy will be drawn by a pen fixed to the other. Using the same principle, different kinds of pantographs are used for other forms of duplication in areas such as sculpture, minting, engraving and milling. Because of the shape of the original device, a pantograph also refers to a kind of structure that can compress or extend like an accordion, forming a characteristic rhomboidal pattern. This can be found in extension arms for wall-mounted mirrors, temporary fences, scissor lifts, and other scissor mechanisms such as the pantograph used in electric locomotives and trams. History: the first pantograph was constructed in 1603 by Christoph Schaner, who used the device to copy and scale diagrams, but he wrote about the invention over 27 years later, in Pantographs. One arm of the pantograph contained a small pointer, while the other held a drawing implement, and by moving the pointer over a diagram, a copy of the diagram was drawn on another piece of paper. By changing the positions of the arms in the linkage between the pointer arm and drawing arm, the scale of the image produced can be changed. A more complicated version called the ideograph was developed by William Wallace in 1831. Uses: drafting. The original use of the pantograph was for copying and scaling line drawings. Modern versions are sold as toys. Sculpture and minting. In sculpture, a three-dimensional version of the pantograph was used, usually a large boom connected to a fixed point at one end, bearing two rotating pointing needles at arbitrary points along this boom. By adjusting the needles, different enlargement or reduction ratios can be achieved. This device, now largely overtaken by computer-guided router systems that scan a model and can produce it in a variety of materials and in any desired size, was first invented by inventor and steam pioneer James Watt and perfected by Benjamin Cheverton in 1836. Cheverton's machine was fitted with a rotating cutting bit to carve reduced versions of well-known sculptures. Of course, a three-dimensional pantograph can also be used to enlarge sculpture by interchanging the position of the model and the copy. Another version is still very much in use to reduce the size of large relief designs for coins down to the required size of the coin. Acoustic cylinder duplication. One advantage of phonograph and gramophone discs over cylinders in the 1890s before electronic amplification was available was that large numbers of discs could be stamped quickly and cheaply. In 1890, the only ways of manufacturing copies of a master cylinder were to mold the cylinders, to record cylinders by the round, over and over again, or to acoustically copy the sound by placing the horns of two phonographs together or to hook the two together with a rubber tube. Edison, Bettini, Leon Douglas and others solved this problem by mechanically linking a cutting stylus and a playback stylus together and copying the Hill and Dale grooves of the cylinder mechanically. When molding improved somewhat, molded cylinders were used as pantograph masters. This was employed by Edison and Columbia in 1898, and was used until about January 1902. Some companies like the United States Phonograph Company of Newark, New Jersey, supplied cylinder masters for smaller companies so that they could duplicate them, sometimes pantographically. Pantographs could turn out about 30 records per day and produce up to about 150 records per master. In theory, pantograph masters could be used for 200 or 300 duplicates if the master and the duplicate were running in reverse and the record would be duplicated in reverse. This, in theory, could extend the usability of a pantograph master by using the unworn lesser worn part of the recording for duplication. Pather Copyright employed this system with mastering their vertically cut records until 1923. A 5-inch diameter, 4 or 6-inch long master cylinder, rotating at a high speed, would be recorded on. This was done as the resulting cylinder was considerably loud and of very high fidelity. Then, the cylinder would be placed on the mandrel of a duplicating pantograph that would be played with a stylus on the end of a lever, which would transfer the sound to a wax disc master, which would be electroplated and be used to stamp copies out. This system resulted in some fidelity reduction and rumble, but relatively high-quality sound. Edison diamond disc records were made by recording directly onto the wax master disc. Milling machines. Before the advent of control technologies such as numerical control and programmable logic control, duplicate parts being milled on a milling machine could not have their contours mapped out by moving the milling cutter in a connect-the-dots fashion. The only ways to control the movement of the cutting tool were to dial the positions by hand using dexterous skill or to trace a cam, template, or model in some way, and have the cutter mimic the movement of the tracing stylus. If the milling head was mounted on a pantograph, a duplicate part could be cut simply by tracing a template. This was essentially the same concept as reproducing documents with a pen-equipped pantograph, but applied to the machining of hard materials such as metal, wood, or plastic. Pantograph routing, which is conceptually identical to pantograph milling, also exists. The development and dissemination throughout industry of NC, CNC, PLC, and other control technologies provided a new way to control the movement of the milling cutter, via feeding information from a program to actuators that would move the cutter as the information directed. Today most commercial machining is done via such programmable, computerized methods. Home machinists are likely to work via manual control, but computerized control has reached the home shop level as well. Thus pantograph milling machines are largely a thing of the past. They are still in commercial use, but at a greatly reduced and ever-dwindling level. They are no longer built new by machine tool builders, but a small market for used machines still exists. As for the magnification and reduction feature of a pantograph, it is achieved in CNC via mathematical calculations that the computer applies to the program information practically instantaneously. Scaling functions are built into languages such as G-code. Other uses, perhaps the pantograph that is most familiar to the general public is the extension arm of an adjustable wall-mounted mirror. In another application similar to drafting, the pantograph is incorporated into a pantograph engraving machine with a revolving cutter instead of a pen, and a tray at the pointer end to fix pre-cut lettered plates, which the pointer follows, and thus the cutter, via the pantograph, reproduces the copy at a ratio to which the pantograph arms have been set. The typical range of ratio is maximum 1:1 minimum 51. In this way machinists can neatly and accurately engrave numbers and letters onto a part. The device, which maintains electrical contact with the contact wire and transfers power from the wire to the traction unit, used in electric locomotives and trams, is also called a pantograph. Some types of trains on the New York City subway use end pantograph gates to prevent passengers on station platforms from falling into or riding in the gaps between the cars. Old-style baby gates used a two-dimensional pantograph mechanism as a means of keeping toddlers away from stairways. The openings in these gates are too large to meet modern baby gate safety standards. Herman Holroeth's keyboard punch used for the 1890 U.S. Census was a pantograph design and sometimes referred to as the pantograph punch. An early 19th century device employing this mechanism is the polygraph, which produces a duplicate of a letter as the original is written. A polygraph is a machine that was and still is used by most government branches for detecting lies of the people they are trying to get information from. The pantograph mechanism helped the idea to scribble figures onto a roll of paper to tell when the blood pressure or pulse changes after the individual hooked up gives a response to the question. Longarm quilting machine operators may trace a pantograph, paper pattern, with a laser pointer to stitch a custom pattern onto the quilt. Digitized pantographs are followed by computerized machines. Lynn Boyd Benton invented a pantographic engraving machine for type design, which was capable not only of scaling a single font design pattern to a variety of sizes, but could also condense, extend, and slant the design. Pantographs are also used as guide frames in heavy-duty applications including scissor lifts, material handling equipment, stage lifts and specialty hinges. Richard Feynman used the analogy of a pantograph as a way of scaling down tools to the nanometer scale in his talk There's Plenty of Room at the Bottom. Numerous trade show displays use three-dimensional pantograph mechanisms to support backdrops for exhibit booths. The framework expands in two directions from a bundle of connected rods into a self-supporting structure on which a fabric backdrop is hung. See also, autopan, James Watt's parallel motion, Polygraph, scissor mechanism, spirograph, references. External links, Pantograph JavaPlet, Pantograph at mathworld.wolfram.com, how to build a pantograph, 3D pantograph process, pantograph cradle used in building facade access system.